Okay, down the stretch on chapter 10, separate compilation. These are just kind of a handful of issues that relate to separate compilation. Remember that we talked about, I don't even remember what chapter, but somewhere earlier, we talked about the classic sequence, right? The classical sequence of language, right? You have this sort of compiling and you have linking and loading, right? These different steps, which are often you use IDEs and stuff, but you can break these steps apart. Well, there's a part where you compile separately and then you link together. Well, it turns out when you do, kind of builds with certain languages, and you've got references in one file, but they need to be seen, elsewhere, that's an issue, right? That's another issue. And it's a funky form of, it's kind of a static scoping issue. But when you're not even, the definition for this thing isn't even in your file, how do you do that, right? How do you support that? So here's a handful of examples. One approach is what C does, all right? C actually does what we can think of as two definitions. One is the actual definition, and the other is a declaration. And this, by the way, in C talk, that's not like a thing. That just means that's how we refer to it in C. That's what that means. So a declaration basically just says name and type, and so I can know that it's a thing, and I can sort of, you know, uh, just keep kind of placeholders for it, right? The compiler can create placeholders for it. Later on, I'll bring the real one in, okay? That's true of functions, true of variables, true of different kinds of stuff, okay? And so if, for example, I wanted to share a variable x, I'd have this int x equals 3 somewhere. Everybody else goes extern int x, and it doesn't have the full thing. Similarly, functions, I can declare functions so that I see them and understand them within the context of what I'm compiling, but I don't actually resolve that until I'm linking, okay? When it goes out and gets the real thing and then pulls that together. And one of the things that's important about that, if you wind up doing, C programming, even though we live in a world of IDEs, you may have a situation where your file works just great when you compile it in C, but then when you go to link it is when it breaks. And you need to understand that there's a linking error that happens because it maybe doesn't find the definition, or you've got duplicate definitions of the same thing, which C is not going to let you do generally. So I think you kind of get the idea on that. So I may have already said most of this. Let's see. Yeah, oh, the last point here that's kind of important, that the declaration doesn't say where to find it, okay? It just says that you got to find it somewhere. It does exist, and by the time you're done linking, you need to resolve it, okay? That's really what it says. Here's another approach in sort of ancient Fortran. There's this notion of a common block, and really what this does is when I say that there's a common block, I'm basically saying that I want to um, lay out sort of variables or things that I want everybody to be able to use, who also defines and uses this keyword common. And what's kind of interesting about that um, is that the common block starts at the same location, okay? So the linker creates one block of memory for the common variables. So if one function goes common ABC and then somebody else goes common XYZ, they refer to the same spots. So you can sort of create a local name that's not the same. But when I say common, I'm talking about the same spots. So I've got to be consistent in everybody's got to use the same type layout for the common to make that work, okay? More modern approaches in Fortran, you've got the ability to do a module, which allows me to define data in separate compilation, but then import those into another file that's sort of separately compiled using the U's. So it's a little bit like the idea where I've got a definition and I've got declarations, but um, the difference is that the use actually has to say what module it's coming from. where unlike in C, where C does not tell the linker where to go find it. It just says, I know there's a thing out there of this type, and I'm going to call it this, and I'm going to use it, and you find it later. Okay. And really kind of a last key point here, where the trends are. Things are a lot more integrated than they used to be, right? Separate compilation is less separate than it used to be. So, there's circular dependencies in Java classes. The Java compiler's got to be able to look at these things kind of simultaneously and not get confused. ML, not really suitable for separate compilation at all, although there are ways to do it, which I don't really care about at this point, and I don't know that you should either, but there is sort of an evolution where, since separate compilation is less of a thing you have to contend with, there's increasingly tools and mechanisms in languages that allow you to to handle that. So here's our conclusion for chapter 10. We talked about different ways of doing scoping, a lot of different variations, and then this one, I don't remember if this was really evoked solidly in the slides, but again, just as a reiteration, that it's definitions that have scopes, not the names. Okay, it's the definition, and the reason, if you think about it, remember back to the various inks in the one example, the various reuse in the classic Java example, which I think shows up, page 159 in section 10.5. It is the definition. And so the names can actually be reused, right? Names can be used over and over. And the fact that, the same name gets used in multiple instances within the same scope, like in ML, if they're a different sort of kind of thing, and ML can tell the difference, that's not a conflict. The issue has to do with the definitions. They're the things that have the scopes. Okay, names just happen to be, part of definitions, if that makes sense. All right, that's it for chapter 10.